All right, so the last kind of problem for molarity is a dilution problem. All right, dilution means we are going to take our solution. So for example, let's say you were sitting at dinner and you ordered tea, and you're sitting here and my wife is there at the table and she ordered tea and they bring her sweet tea by mistake. Well, what's she going to do? She might ask for another glass. She might ask for a glass of water, and she's going to take that tea and she's going to dump the water into the tea, and that is going to dilute, that is going to weaken the sweetness of that tea. And so that's what these problems are. We're going to take a solution. We're going to take an original solution. So here we have 50 milliliters, by the way. This could be in milliliters. It could be in liters. We're going to take that solution of original concentration. We're going to change its volume. We're going to add water to it. In this case, 0.1 liters. We're going to add 0.1 liters to it. And then we're going to see what the new molarity is. Now, to do that, we use a very specific equation. Pause here if you need to write this down because it's about to get kind of scroll away here. To be able to do this, we're going to use an equation that we're going to use a lot in chemistry. All right, we're going to use it a lot for the rest of the semester. I call it the dilution equation because it's the first time we use it. Lots of people have lots of different names for it. Some people call it the titration equation. And there are a couple of different ways to write it. I prefer to write it as M1. And that M is a capital M. And I think I've already done this in a couple of videos, but just to explain to you, when I use a capital M to make sure I show it's capital, I'll put these little feet on there, right? That means capital M. M1 times V1, and V here is volume, equals M2 times V2. So this is the dilution equation. We're also going to use it as a titration equation. You're going to see it again. I guarantee it. It's worth memorizing. Capital M times capital V equals capital M times capital V. And you'll see some people use A and B instead of 1 and 2. Doesn't really matter. All right. So M1 is the original concentration. I'm going to write out concentration. And V1 is the original volume, or you could think of it as the initial concentration, the initial volume, right? If you heard that in physical science, that's cool. M2 then is the changed or final concentration, and V2 is the final or changed volume. This is supposed to say volume. I realize it looks like VD. Not a chemistry thing, all right? So M1V1 equals M2V2 is how you often hear people say this. So what we're going to do is we're going to plug in our numbers from the equation up here. So for us, M1 was equal to, and I'm getting worse about putting my feet on here and making my ones look like ones, but the original molarity was 0.450. Doggone it, 0.450. There we go, just a simple little mistake. 50 molars. Molars is how most people pronounce that. Molars. There we go. V1 was equal to, well, the original volume is in liters. Right? It's right there, 0.050 liters. M2, well, we don't know. It's asking us what is the new molarity, what is the changed molarity. So I'm going to put X in for that one. And then you can use any variable you want. You could leave it as M2 if you wanted to. That's cool. V2 is the new volume, and that one is 0.150 liters. So now all we got to do is a little bit of algebra. We're just going to take these guys, and we're going to plug them into the equation. So it's M1, 0.450 times molars times, I didn't need the times in between there. I'm sorry, folks. I was jumping ahead of myself. times 0.050 liters equals X times 0.150 liters. So how do we get X all by itself? Well, we need to get rid of this part, this number over here, so we're going to divide by 0.51, doggone it, 50 liters. Okay, right, because that'll cancel those guys out. Anything you do to one side, you got to do to the other side. 150 liters. Good old simple algebra here, right? You got to love that. By the way, this is as complicated as it gets right here. This is it. So you master this, and you're good, okay? So what cancels out? Well, anything on the top and the bottom cancels out. Gone, gone. And over on the left-hand side, we've got liters on the top and on the bottom. Let's X that out. All right. So X is going to have units of molarity. Is that what we want? It's asking us what is the new molarity. So check. That is exactly what we want. So to find what goes on the left here, we got to plug this into the calculator. It's 0.45. Doggone it. Turn on my calculator. 0.45 times 0.05 divided by 0.15 equals, the new molarity is 0.150. Oh, don't forget units on there. Molarity. And we knew it was molarity because that was the only thing that didn't get canceled out. That's the answer. Just a little algebra.